Uh, Firstly, I want to say something that this is my first class. So if anything goes wrong, then please forgive me because this is my first time. I'm I'm doing this for first time. So if there's always a chance that if someone is doing something new or doing something first time, then there always a chance that he will do something wrong. Okay, so if anything goes wrong, then please forgive me. Okay, so let's start it. So what is thermodynamics? Thermodynamics. Thermodynamics is okay. First, thermodynamics. Thermodynamics. Okay. First, thermodynamics is the branch of engineering. Thermodynamics. Thermodynamics is that branch of engineering where we deals with what? Where we deals with science with the energy possessed by gas and vapors. Okay, so here's nothing. So tell me first, the energy or vapor which possesses the vapor or gases which possesses energy. Okay, so first see that light is a form of energy. Okay, air is a form of energy, and there's so many things. And the one thing I must say that this one has also energy. Okay, but the energy is more compressed, and the energy is more in a more compressed form that we cannot feel directly. Okay, so we cannot use it, properly or directly. We have to change this Walls material into another form so that we can use it for our required purposes. Okay, so light is a form of energy, air is a form of energy, same as vapors, gases is vapor gases also possesses energy. Okay, there's so much of energy in that, in gases, in vapors. For that we use gases and vapors for boiler machines. Okay, for boiler machines, if gases and vapor does not have energy, if they don't have any energy, then we cannot use it for our boiler purposes. So gas is a form of gas is a form of energy. First, gas is a form of energy like light. Okay, gas is a form of energy like light. Okay, then vapor, form of energy like vapor is a form of energy like air. Okay, light and air. So this is a form of energy like an air. Okay, I think you understood this, that these are form of energy and we use it for our boiler engines to turbines, to rotate the turbines, and steam engines also. Okay, where the steam do the main steam do the main work in steam engines. It rotates the engines. It changes the volume of the pistons in the steam engine, the gases. Okay, so what we will say? Okay, what are the types of thermodynamic system? What are the types of thermodynamic system? Let's start. Thermodynamic system. Okay, thermodynamic system. How many thermodynamic systems are present in our universe? First, open system. Okay, open system. What is open system? Open system is a type of system in which heat, work, and mass can interact with the surroundings. Okay, let's see open system. Okay, I will not teach you theoretically, but I am trying to teach you in more practical manner. Okay, so that you can understand it well. I've seen that so many platforms like physics for I'm not taking name, sorry, extremely sorry, like so many platforms they teach more theoretical, they teach in a more theoretical manner. So I think that's not good for learning. Okay, the thing I am trying to do is to teach you is to teach you in a practical manner. Okay, so what is open system? Open system, like this is a bucket. Okay, this is full of water. Hmm? This is full of water, and it is open, like it is not covered. Like I'm telling you, this cover, it does not, it does not have this cover. Okay, so it can directly interact with the surrounding, so that it can directly interact with surrounding. Like this is surrounding, this is the form of surroundings. Hmm? Form of surroundings, this is a surrounding. This is also surrounding. Okay, so this contains mass, system, heat, water. Okay, like it has mass, heat, and water. Okay, so these three things, this mass, this heat, and this water, these three things can interact with the surroundings directly. Okay, so this is the open system. Hmm. Okay, so this is the type of system. So this is system. Okay, this is system, and this is boundary. Boundary. I hope you're seeing. Okay, this is system. Okay, please forgive for my handwriting. Okay, I will make it more beautiful in coming videos. Okay, so please forgive me for this handwriting. Okay, I'm so sorry for this. Okay, so this is a system, and this is surrounding. Okay, this is surrounding. Hmm? Okay, this is a more complex matter. One thing I need to do. Okay, first erase it. Open system, like this is like a okay, this is system. This is boundary, and this is surrounding. This is surrounding. Okay, this is surrounding, this is surrounding, this is surrounding. And in open system, this system can directly interact with the surrounding. To which property the systems have can directly. Okay, in this, suppose this system has heat. This system has work, heat, work. Heat can directly, heat interacts with the surroundings very in a good manner. Okay, heat and work both interacts with the surrounding. Okay, suppose this is heat, work, and mass. These three things can directly interact with the surrounding. Okay, and okay, suppose the second part, the second type of thermodynamic system is isolated system. Okay, second is isolated system. Suppose isolated system okay, isolated system in isolated system and this surrounding is okay, in isolated system heat and work does not interact directly with the surrounding. Okay, only mass can interact with the surrounding. So this is a kind of property. Okay, this is a kind of specialized property for isolated system, that only mass can interact with the surrounding. Only mass can interact with the surrounding, but heat and work cannot. So this is a broader. I'm not going to so much deeper, because this only if you are preparing for GATE or any competitive exams, then this much amount of knowledge is enough. You don't have to do PhD in this. Okay, so this is for isolated system, and then comes the closed systems. In closed system, heat, work. Okay, this heat, work, and mass. These three things cannot interact with the surroundings. Okay, these three things cannot interact with the surroundings. Okay, but in isolated system, only mass can interact with the surroundings. In open system, these three things can interact with the surroundings. But in closed systems, this is heat, mass, and work. These three properties cannot interact with the surroundings. So this much amount of knowledge is enough. If you want that I need to go deeper in this subject, or in this in this topic, then I will go. Okay, so let me know in this comment section. Okay, what are the properties of system? Okay, so first we need to know that what is property. What are the properties of the system, and what is property of the system? Okay, so the state of the system. Okay, what is the properties of the system? The properties of the system properties of a system. Properties of the system. The state of a system may be defined on what? Okay. All the quantities. Okay, what are the properties? Properties of a system. What is properties? First, we have to know that what is properties. Okay, what is properties? All the quantities which identify the state of a system are called properties. All the quantities which identify identify the state of a system, the state of a system, identify the state of a system are called properties. Okay, are called properties. So what are the properties? I don't know quantities. Okay, so first then we have to know that what are the quantities that defines the state of a system. Okay, what are the quantities that defines the state of a system? So then first there comes the volume. Okay, volume. Then comes temperature. Then comes temperature, and then comes pressure. Okay, pressure. These are the three quantities which defines the state of a system. These are the three quantities which defines the state of a system. So then what is volume, what is temperature, and what is pressure? I think you guys all know these three things. I don't think that you guys are class 5-6 students. Okay, I think all those who are watching my video, I think they know that these three things these three things are what. Okay, so I'm going directly to the properties of thermodynamic system. So I hope you understood that what is properties, that all the quantities which define that, all the quantities which defines the state of a system are called properties. The quantities that I'm telling you that if there are water is liquid. So if water is liquid, then it is water is liquid. What is the state of water? The state of water is liquid. Okay, if the state of water is liquid, then what are the quantities, or what are that variables which is defining that water is a liquid? We can define that water is a liquid with these three properties: volume, temperature, and pressure. Okay, suppose water has no volume. Okay, it can take any shape like any. Okay, if we pour the water in a bucket or a bowl or a cup, then it takes that shape. But it has volume, and the unit of volume is meter cube. The unit of volume is meter cube. Temperature, Celsius, Fahrenheit, and these are for SI unit, and for CGS units like Kelvin. Okay, Kelvin, and so on. So these are, and pressure for Pascal. Pascal is for and these are the things. And what is the CGS unit? Okay, it doesn't need. If SI unit involves more, okay, this Pascal. Okay, then straight goes to the properties of thermodynamic system. Okay. First, properties of a system. Properties of a system. First extensive properties. What is extensive properties? Extensive properties. Okay. What is extensive properties? What are the extensive properties? The properties of a system whose value for the entire system is equal to the sum of the values for the individual parts of the system are called extensive properties. For example, total volume, total mass, total energy of the system are extensive properties. Okay. First, the properties of the system whose value for the entire system is equal to the sum of the values for the individual parts of the system. Suppose if I tell that this is a substance, okay, this is a substance, this is a substance in which volume. If I talk about the three properties, like it has three properties, three quantities: volume, temperature, and pressure. If I talk about extensive properties like volume, like volume, what is volume? Volume is 3 meter cube. Temperature is 0 degree Celsius, okay, and pressure is suppose 100 pascal. Temperature is 100, pressure is 100 pascal. So this is if I am telling you how the volume, this 3 meter cube, is coming. How do we know that this whole substance, suppose this is a whole substance, volume is 3 meter cube. How? 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 This volume is 3 meter cube. Suppose 3 meter, its volume is 3 meter cube. So it has molecules inside. It has molecules inside. Okay. It has molecules. There are so many molecules and particles inside, like infinite amount. It has infinite amount of particle. Okay, it has infinite amount of particle this substance contains, and each molecule or each particle of this substance contains a small amount of occupying small amount of volume in this substance. Okay, I'm again telling you, please sorry for my handwriting. Okay, I will make it more beautiful. This each molecule or particle in this substance contains or occupying small amount of volume in this substance, and this 3 meter cube is equal to infinite amount of molecule which occupying the volume of the substance. Okay, this infinite amount of molecule which occupying the volume of the substance is 3 meter cube. That means if suppose this molecule or this particle, suppose occupying, suppose I am telling you suppose, but this is not the example. Suppose 0.1, 0.1, what I tell you, centimeter cube, no, centimeter cube not, millimeter cube. Suppose this each molecule, or it can go more, micrometer. Suppose it's called a micrometer. Then my micrometer. Okay, micrometer. This each molecule 0.1 micrometer, occupying 0.1 micrometer cube in this substance. Then this 0.1 micrometer cube occupying this substance, and this how many suppose infinite amount of molecules or particles present in the inside this substance, and this infinite amount of particles or uh, molecules occupying 0.1 micrometer cube of space in this substance, and this infinite amount of particles is equal to 3 meter cube. Suppose 3 meter cube is equal to, okay, I'm telling you this will look so crazy. Okay, 3 meter cube is equal to 3 meter cube is equal to 0.1 plus 0.1 plus 0.1 plus 0.1 plus 0.1 plus 0 infinite. It's going to infinite. So 3 meter cube is equal to that infinite amount of particles or molecules in this substance occupying this 0.1 micrometer cube in this substance. This gives the volume of 3 meter cube in this substance. Okay, so volume is 3 meter cube, means each molecule or each particle in this substance which occupying a little volume, this gives the value that this substance has volume of 3 meter cube. So the 3 meter cube has little like 0.1 contributions of each molecule or each particles in this substance. Okay, so each particles has same amount of contribution for this value 3 meter cube. Okay, so let's erase this. Took so much time for this. Okay, I hope you guys know. Extensive properties. Okay, so what I'm telling you, the extensive properties. Okay, extensive properties mean total. Extensive property means total volume. Total volume. Okay, total volume. First, total volume, then total energy. Okay, so I'm not going deep because it's taking so much time. Okay, I'm not going so deep. Total energy and total energy of a system and total volume of a system. Total volume of a system. These are some extensive properties. The properties of system whose value is equal to the sum of the values in individual parts of the system. So extensive properties is like individual parts of system when we combine the contributions of each part of the system, then it gives a extensive property. Okay, that means each contributions of particles, molecules, atoms, everything. Okay, everything. So whose contributions gives the extensive property. Each contribution matters. Suppose I am then going to intensive property. Intensive property like intensive properties like the properties of whose value is not equal to the sum of the value. Okay, the properties of the system whose value for the entire system is not equal to the sum of the values is not equal to the sum of the values of the individual parts of the system. That means intrinsic properties are those properties like temperature, like pressure, like density, okay, density